Hi all, today we discuss the last two interpolation formulas, the Laplace formula. This is yp is equal to q times y naught. This contains two terms, two infinite terms. Okay, this contains infinite terms and this contains infinite terms. Even though it contains infinite terms, for the practical or application level, we will choose the first two terms of this bracket and first two terms of this bracket. That much terms are enough to get the approximate value of y. Okay, so we can neglect all those higher orders of differences. So please keep in mind that yp is equal to q y naught. This q is obtained from p, that is 1 minus p is equal to q, or other way p plus q is equal to 1, and p is obtained from this formula, x minus x naught divided by h. Okay, now we can discuss a example. This is the example. Use average formula to obtain f of 1.15 given that f values are here. Okay, so we construct the table. Here we have x values. X values 1, 1.10, 1.20 and 1.30. We have only 4 points, and the corresponding function values are given, that is 1. And before that we write f value here, that is 1.049. this is 1.096. this is 1.140. Okay, before that, before we calculating this table, we write p. What is p? By definition, p is equal to x minus x naught divided by h. Okay, first we have to set x naught. We need to find the value of 1.15. That is in between this 1.110 and 1.10 and 1.20. So 1.10 is to be selected as a x naught. So we write x naught is equal to 1.10 divided by h is equal to the length of the intervals. So that is 0.1. Okay, that is 0.1. Now this is our x value. So using this, this is our p value. Using this p, you can evaluate q by 1 minus p by this formula. So first of all, we evaluate this p. Our x naught is equal to this, so we write p is equal to 0 here, and here we have minus 1 and 1, and this is 2. So these are the p values. So let's complete the table. Delta f, okay, delta y or delta y. What is delta y? The difference between these two. So that will be this minus this, so that is 0.49. So 0.049, and this will be 0.047. this will be 0.044. okay, now the next order, delta square y. Okay, we are using this delta square. This is our y. Delta square y is difference between these two, so that will be minus this one, minus 0.002, and we have difference between this minus 0.003, and we have delta q. We are not using this anyway. We write minus 0.001. okay, now you evaluate the value of this y at x equal to 1.15. So that corresponding p will be 1.15 minus 1.10 divided by 0.1, that is equal to 0.5. okay, so this is the p value. The corresponding q value will be 1 minus this, 1 minus 0.5, so that will be this 0.5 again, 0.5. so this q value and p value are the same. Okay, now you evaluate this formula. So the formula is, we will write the first two terms of this formula only, the first two terms. So that will be, I will write here yp, that is our y value, required y value. So the first term will be q times y naught, that is 0.5 times y naught. which is y0. Y0 is this value 1.049 plus the second value will be 0.5 into q square, that is 0.25 minus 1, that is q square minus 1 square divided by 3 factorial, and delta square y minus 1, that is delta square y minus 1. So this is our delta y minus 1, and this is in fact this is our y minus 1, and this is not, this is y minus 1, this is y minus 2, sorry, this is y0, and this is y1, and this is y2. So these are the values. So this will be a delta y minus 1, and this is going to be the delta square y minus 1. So we write it as this times minus 0.002. Okay, so these are the first two terms of the first bracket, and next we choose the first two terms of the next bracket. So that will be this plus we have p times y1. Okay, so we have 0.5 times y1. What is y1? Y1 is this number 1.096. okay, so the second term will be 0.5 times y1, p times p square minus 1 square, that is again 0.25 minus 1 divided by 3 factorial into delta square y0. What is delta square y0? This is delta y0, and this is our delta square y0. Okay, so we choose this one. Delta square y0 is minus 0.003. So we take only this much terms and simplify this. Okay, when you simplify this, you can get the value as 1.07282125. Please verify this number, and this is going to be f of 1.15. So this is the way we use this Laplace formula to evaluate f of 1.15. okay, next we will discuss the one more formula, that is what we called Newton's divide difference formula. So this is the last formula explained in this session 22.9. Now we have a formula, divide difference formula. So this is defined as, let f of x0, f of x1, etc., f of xn be the values of the function f of x corresponding to the arguments x0, x1, x2, etc., xn. Then we define the first difference, divide difference, for the arguments x0, x1. Okay, so the contrast to the previous case, as we pass arguments x0 and x1 to get the divide difference formula. This is defined as f of x1 minus f of x0 divided by x1 minus x0. So this is denoted by the symbol f of x0 comma x1, or you can use the symbol delta x1 f of x0. Okay, so this is another symbol for this divide difference, and or you can use x0 x1. Okay, so these are the notations to define to denote this f of x1 minus f of x0 divided by x1 minus x0. Okay, so this is the difference. Using this divide difference, we will explain one more divide difference formula. So we write it as 22.9 G is Newton's divided, this is divided difference formula. This is f of x equal to f of x0 plus x minus x0 delta x1 f of x0. So this is f of x1 minus f of x0 divided by x1 minus x0. So that is the symbol here, and the next term will be x minus x0 into x minus x1 times delta square x1 x2. Okay, so this is of f of x x naught. Okay, so this is the second order divided difference formula. Okay, so that is obtained from this. Okay, so that is what is the second order divided difference formula. So this is defined as we will write the definition of this later. So times this times this plus etc plus, finally since we have n arguments, then the last term will be x minus x naught into x minus x1 into etc x minus xn minus 1 times delta n x1 etc xn f of x naught. Okay, so here we define this delta square of x1 x2, this f of x naught. Okay, so we know that what is this one, delta x1 f of x naught, that is f of x1 minus f of x naught divided by x1 minus x naught. So what is the square, second order divided difference formula? Okay, so that is defined as f of x1 x2 minus f of x naught x1 divided by this x2 minus x naught. So this is the second order divided difference. This is also denoted by the symbol x1 x2 x naught x1 x2 or you can use f of x naught x1 x2. So this is nothing but f of x1 x2 minus f of x naught x1 divided by x2 minus x1. Similarly, you can define the third order delta cube x1 x2 x3 of f of x naught. Okay, so by definition this is equal to f of x1 x2 x3 minus f of x naught x1 x2. Okay, so to write the first term we use this one, and for the second term we start with this x naught x1 x2 divided by x3 minus x naught. So this is denoted by x naught x1 x2 x3, or you can write f of x naught x1 x2 x3. Okay, usually we use these symbols to denote these numbers. Okay, now we will discuss a problem or illustrative example for this. So that is our example. Using Newton's divided difference formula, evaluate f of 8. Evaluate f of 8 and f of 15. We have two questions, f of 8 and f of 15. Given that we have x values here, x equal to 4, 5, 7, 10, 11, 13. These values need not be in equal intervals. This is our f of x. The values 48, 100, 294, 900, 1210, 2028. So these are the values. So using these values we need to find out the value of f of 8. Okay, now we start the table, that is 4, 5, 7, 10, 11, 13. These are the values, and this is x values here, and this is f of x is here. This is f of x, that we have 48, 100, 294, 900, 1210 and 2028. So these are the values. Now we have to evaluate delta f of x. What is delta f of x? Delta f of x, here delta f of x is the divide difference, so that is denoted by delta x naught. This is our x naught, x0, x1, x2, x3, x4, x5. So this is delta x1 of f of x0. Okay, how will you find this? This is f of x1 minus f of x0. So that is 10 minus this is 100 minus 48 divided by, this is obtained as 100 minus 48 divided by 5 minus, so this is x1 is 5 here and x0 is 4, so you can write it as delta 5, this is, you write it as delta 5 4, so this is x0, this is x1, okay, that is here x1 minus x0, that is equal to, the value here is 52. Okay, so similarly we write, so this is in between these two, this is in between these two numbers, and we write the next delta 7 of f of 5 here, so that is obtained by 294 minus 100 divided by this 7 minus 5. Okay, so that will be 97, and next we have delta 10 of f of 7, that is 900 minus 294 divided by 10 minus 7, that is equal to 208. Okay, now we have delta 11 f of 10, so that is nothing but 1210 minus 900 divided by 11 minus 10, that is equal to 310. Finally we have delta 13 of f of 11, that is equal to, in the denominator we have 13 minus 11 obviously, so the numerator will be 2028 minus 1210, so this will be 409. Okay, now you evaluate delta square of this, okay, delta square of x, so this is divided difference, so that is obtained by taking the difference between these two. Okay, so that is denoted by delta 5 7. Okay, so this comes from these two numbers 5 and 7, f of 4, delta square 5 7 f of 4, and this is obtained by taking the difference between these two, 97 minus 52, so this is f of this 5 comma 7 and this is f of 4 comma 5 divided by the difference between these two numbers 7 and 4. Okay, so that is the difference between these two, that is 7 minus 4, that is equal to 15. Similarly you can evaluate delta square of this 7 10 f of 5, so that will be 292 minus 202 minus here, sorry, 208 minus, so this is in fact 202 because this difference is always 202 minus 202 minus we have 97 divided by 10 minus 5, this minus this number 10 minus 5, that is equal to 21. Okay, now you evaluate the third case, that is 10 11, and this is f of 7, this will be 310 minus 202 divided by 11 minus 7, that is equal to 27. As similarly the final one will be delta 11 13 f of 10, that is 409 minus 310 divided by 13 minus 10. Okay, so that is nothing but 33. Now you evaluate the final order divided difference, that is delta cube of f of x, so this is denoted by the symbol delta cube of three things, that is 5 7 10 of f of 4. Okay, so this is the denominator, we have difference between these two, 10 and 4, 10 minus 4, and the numerator we have these two differences, that is 21 minus 15, which is equal to 1. Okay, similarly you evaluate this one, that is delta cube of 7 10 11 of f of 5, so that will be the difference between 27 and 21, 27 minus 21 divided by 11 minus 5. Okay, so that will be 1 again, and finally we have this one, delta cube of this 10 11 13 f of 7, that will be difference between these two, 33 minus 27 divided by 13 minus this 7, okay, which is also equal to 1. So these are the table values. So using this table value, we evaluate this formula. Formula is given here, f of x equal to f of x naught plus this x minus x naught into this plus etc. Okay, so finally we write the formula, that is y f of x equal to f of x is we need to find out the value of f at x equal to 8. So we evaluate f of, first we write f of x, that will be f of 4, this is x naught, plus x minus x naught, that is x minus 4 into delta 5 of f of 4 plus x minus 4, this is x minus x naught, and x minus x1, that is x1 is 5, so we have 5 here, into delta square 5 7 f of 4 plus x minus 4 into x minus 5 into x minus 7 times delta cube 7 delta cube into 5 7 10 of f of 4, and the fourth term will be this delta raised to x minus 4 into x minus 5 into x minus 7 into finally we have x minus, so we have only 3 third order, so we need to worry about these things. Okay, so just remove that. So which is equal to, what is f of 4? F of 4 from this table we have f of 4 is equal to 48, so we have 48 here, okay, plus x minus 4, so we need to evaluate f of 8 first, that is 48 plus 8 minus 4 times this value delta 5 f of 4. What is delta 5 f of 4? That is 52, so we choose this one. First we choose this 48, then we choose 52, so this is into 52 plus 8 minus 4 into 8 minus 5 times that number, which is 15, this is 15 plus we have 8 minus 4 into 8 minus 5 into 8 minus 7 into this value, that is 1, so that is 1. Okay, so we will have this is equal to 448, so this is the value of f of 8. In similar fashion you can evaluate f of 15. The only difference is we start with this 48 and we have x minus 4 here, that is 15 minus 4. Okay, here we have the same thing, and the next time we have 15 minus 4 into 15 minus 5, etc. Okay, so you will get the value as f of 15 as 3150. Okay, so these are the two values. So with this example we can conclude section 22.9. So we have seen some central difference interpolation formulas. So these are the important central difference interpolation formula: Gauss forward interpolation, Gauss backward interpolation, Stirling formula, Bessel's formula, Laplace-Everett's formula. You have seen one more thing, Newton's divide difference formula, but I wish to give you some remarks on these 5 central difference interpolation formula. So we use Gauss interpolation, Gauss forward interpolation if the interpolation is required near the beginning of the table. Okay, so if our interpolation is required near the end of the table, we use this Gauss's backward interpolation formula. So these are the 2 remarks on these 2 Gauss's interpolations. Forward interpolation is if we require the interpolation near the beginning, near the end we will use the backward interpolation. Okay, all other interpolations, that means interpolation is required near the center, we can use one of these 3. Okay, so if the p value, the p lies in between minus 1/4 and 1/4, it is preferred to use Stirling formula, so that will give more accurate value for that. Okay, so if the same if the interpolation is required near the center, we will use Bessel's formula if or it is preferred if 1 by 4 less than p less than 3 by 4. The same thing can be used if it is preferred, the same condition 1 by 4 less than p less than 3 by 4, we will use this average formula. Okay, you can choose one of these formulas for interpolation required near the center. Okay, so if you use these type of preference, then you can get the more accurate solution or more easily convergent solution for this. Okay, so these are some remarks on five central difference interpolation formula. Okay, next we will discuss the last the 22.10 of this module, that is numerical differentiation. After that we will move on to the numerical integrations. Okay, so next we will discuss 22.10. This is the numerical differentiation. In order to evaluate f dash a, h times f dash a, we will use del, this is the forward difference, del f of a minus 1 by 2 times del square f of a plus 1 by 3 times del cube minus 1 by 4 times del raised to 4 f of a. So using the different orders of forward differencing, we will use this, we will find this h times f dash a. Similarly, h square f double dash a is equal to del square f of a minus del cube f of a plus 11 by 2 del raised to 4 f of a minus 5 by 6 del raised to 5 f of a plus etc. Similarly, h cube f triple dash a, so the third derivative of f at x equal to a can be obtained using this formula. Okay, similarly, using the backward difference, we can write this derivatives using backward difference del f of a. So this is the backward difference formula. So it will not be so easy to remember all this. So I'll explain how to get these formulas. In order to get the higher order derivatives, you need to you should be able to write the formulas. So that is from this Newton's forward interpolation formula. You must by heart this one. This is we discussed this earlier. F of a plus h, f of a plus x plus x times h equal to f of a plus x times del f of a plus x into x minus 1 into del square f of a plus etc. So if you differentiate this expression, okay, differentiate this expression with respect to x, okay, then you will get h times, what is the derivative of this, x h times f dash of a plus x times h. Derivative of f of a will be 0. Derivative of this will be 1 times del f of a, and similarly you can write all the derivatives of these things. First of all, you expand this bracket and take the derivative. Del square f of a is independent of x, that should be kept as it is. Similarly, you can find the derivative of all these terms. Okay, in that expression, if you put x equal to 0, I'll write one more expression here. First we take the derivative of this, you will get this one, h times f dash of a plus h, a plus xh equal to f of a. The derivative of f of a will be 0, so we write it as 0, plus derivative of x will be 1 times del f of a, and this is x square minus 1. Okay, x square minus x, the derivative of x square minus x is 2x minus 1 divided by 2 factorial again, and del square f of a plus, and you expand this, this will be a third degree polynomial, say 3x square minus 6x plus 2. You can multiply all these three factors, then that will be, I'll write the polynomial here, that will be x cube minus 3x square plus 2x. Okay, so this is the this factor. Then take the derivative of this, that will be 3 times x square minus 6x plus 2 divided by 6 times del cube f of a plus etc. This is the way we write this expression. In this expression, similarly you can write the second derivative from this. Okay, find the derivative of this again, that will be h square f double dash of a plus xh, that will be the derivative of this quantity will be 0, and derivative of this will be derivative with respect to x, that will be 2 by 2, that is 1, then 1 times del square f of a, so that will be the first time will be del square f of a, and you can differentiate this again, that will give 6x minus 6 divided by 6 del cube f of a, and so on, 6 del cube f of a plus etc. So similarly you can find the third derivative, fourth derivative, etc. Okay, so in order to get the first formula defined here, we need to put x equal to 0 in this expression. When x equal to 0 in this expression, we will get h times f dash of a plus 0 times h, that is f dash a. So that will give the left side, and on the right side we have the second term starting from del f of a minus we need to put x equal to 0 here, so that will be minus 1 by 2, so that is minus 1 by 2 times this, and when you put x equal to 0 here, that will be 2 by 6, that is 1 by 3 times this, etc. So in order to get the second formula, you need to put x equal to 0 in the second expression. Okay, similarly you can write the third derivative and put x equal to 0, and then you will get all these formula. Okay, forward differences. Now if you start with the Newton's backward interpolation formula, if you perform the same thing, you can get these formulas, backward differences formula. Okay, so these are the two important formulas in numerical differentiation. Now we will discuss one problem of this forward difference and backward difference, then we can conclude section 22.10. This is our example. A slider in a machine moves along a fixed straight road. Its distance xcm along the road is given below for various values of the time t seconds. Find the velocity and acceleration of the slide when t is equal to 0.3 seconds. Okay, so this will be the model question, or this is an illustrated example. So we have to find the velocity at t equal to 0.3. T is equal to velocity at t is equal to 0.3 seconds. So this is nothing but f dash of 0.3. Okay, so similarly the acceleration. Okay, acceleration at a t is equal to 0.3 is nothing but f double dash of 0.3. Okay, where this x equal to f of t. If you set this, these are the functional values. This is our f of t and this is our t. Then you can, using these much values, only these much values, we can find the approximate value for this f dash of 0.3, or the velocity at t is equal to 0.3. So this is one of the applications of this numerical differentiation. So in order to evaluate this f dash of 0.3 and f double dash of 0.3, we will use the Newton's backward differences and forward differences. So here we use Newton's forward difference formula. So you can choose, if you are remembering that formula, you can directly write that formula, or otherwise you can construct that formula. You can derive that formula and apply t is equal to 0.3. Anyway, we must have the table, a forward difference table, to evaluate this velocity and acceleration. So first of all, we construct that table. This is our table. These are the t values and these are the x values. We need to evaluate f dash of 0.3. So we need to put a is equal to 0.3. So we set this is our a. So in the formula we will use del f of a, del square f of a, del cube f of a, and so on. So we write these values, fill these values. Del this is our a, so we write so we set a is equal to 0.2. This is not a, this is in fact a plus xh. So we use this is our a plus xh, okay, and then this will be our a is equal to 0.2 and our h is equal to 0.1, the distancing is 1. Then this will be a plus xh, okay. So what is a plus xh? A plus xh will be 0.2 plus 0.1. So this is a plus th. Instead of x we have a plus th, so that will be a plus th will be 0.3. So that is the identification. Now then obviously t will be t is equal to 0.3. Okay, so this is obtained by solving this. Put a is equal to 0.2 here and h is equal to 0.1, then you will get this t is equal to 0.3. This t is equal to 1, not 0.3. So this is a 1. Okay, this is obtained by solving this equation. A is equal to 0.2 plus t times h is equal to 0.1, that is equal to 0.3. Okay, from this you can write t times 0.1 is equal to 0.3 minus 0.2, that is 0.1 again. So from this equation you can get t is equal to 1. Okay, now we complete this table from this, okay, because this is our a, so we need to get a del f of a, del square f of a, del cube f of a. So you are not bothering about these values. Okay, so from this you can write del f of a. Del f of a will be 0.77. you can write these things, but we are not going to use that those values, so we are concentrating only on these values. Okay, so this, if this is a, then this is our f of a, and this will be del f of a. Okay, so here we have 0.31, this is minus 0.41, and this will be minus 0.51. okay, so this is similarly you can write this values here, so but we are not bothering about those. Now we have, this will be minus 0.46, this is our del square f of a. Here we have minus 0.45, here minus 0.43. okay, similarly take this difference 0.01, this will be del cube f of a, and here we have 0.02, and this is our 0.01, this is del raised to 4 f of a. Okay, we are bothering only about these values. Okay, this is our f of a, and this is our del f of a, this is del square f of a, del cube f of a, and del raised to 4 f of a. Okay, so using these values we will find the value of f of a plus th. Okay, now we have a plus, we write the formula, we have f of a plus th equal to f of a plus t times del f of a plus t into t minus 1 by 2 factorial. This is del square f of a plus t times t minus 1 t minus 2 divided by factorial 3 del cube f of a. We will write one more term, so because it contains only del raised to f of a, so t into t minus 1 into t minus 2 into t minus 3 divided by factorial 4 del raised to 4 f of a. Okay, now take the derivative of this, otherwise you can expand this all these things, so that will be f of a. Before we go into differentiate, we expand this brackets, this is del f of a plus this will be t square minus t divided by 2 factorial, that is 2 itself, t square minus t divided by 2 del square f of a plus this will be t cube minus 3t square plus 2t divided by 6 del cube f of a and this polynomial will be t raised to 4 minus 6t cube plus 11t square plus minus 6 minus 6 t divided by 24, that is for factorial, times delta raised to 4 f of a. Okay, now differentiate this. So okay, when you differentiate this, you can get h into f dash of a plus th. Okay, so that will be this is th, that will be del f of a. By differentiating, we can cancel this. From this you can write del f of a, and the next term will be 2t minus 1 divided by 2 del square f of a plus 3t square minus 6t 6t plus 2 divided by 6 del cube f of a. So this is the last term will be 4t cube minus 18t square plus 22t minus 6 divided by 24 del raised to 4 f of a. Okay, from by putting a plus th is equal to 0.3 with a is equal to 0.2 and h is equal to 0.1, t is equal to 1, you can get this expression. Okay, so this will give the derivative. Since h is equal to 0.1 times this will be you can easily get a number here, and by dividing that by h, you get that f dash velocity. But we are asked to evaluate acceleration as well, so we will differentiate one more time, h square f double dash of a plus th. Okay, so this will be del square f of a, so that is a derivative of this, and del square f of a in the first term, and the second term will be 6t minus 6 divided by 6, that is t minus 1 times del cube f of a, and we have this 12, the derivative of this, that is 12t square minus 36t plus 22 divided by 24 del raised to 4 f of a. Okay, so these are the formula. If you are remembering this formula, you can direct write this formula. Okay, now you substitute for the values, h is equal, substitute these values, h is equal to 0.1, a is equal to 0.2, and t is equal to 1. So that will give 0.1 times, from this you can write 0.1 times f dash of this value will be 0.3, that is equal to you substitute for this del f of a, that is 0.77, and plus 2 times t is 1, that is 2 minus 1 by 2, 2 minus 1, that is 1 by 2 itself, times del square, that is minus 0.46. Okay, so what will be the third term? Third term comes from this, that is by putting t is equal to 1 here, that is 3 minus 6, that is minus 3 plus 2, that is minus 1, that is minus 1 by 6 times del cube f of a. What is del cube f of a? Del cube f of a is 0.01, so this time 0.01 plus the fourth term, the last term will be when t is equal to 1 here, you will get 4 minus 18. 4 minus 18 is I think minus 14. Minus 14 plus 22, minus 14 plus 22 is again 8. Okay, 8 minus 6, that is 2, then that will be 2 by 24. Okay, 2 by 24 is 1 by 12, that is 0.01, that comes from this, that is del raised to 4 f of a. Okay, so when you simplify this or from this you can extract f dash of 0.3. so this is the velocity. So the velocity will be 5.34 meter per second, centimeter per second. So this is the value of the symbolize, we write like this, we symbolize velocity, we will write it as, by simplifying this you can write f dash of 0.3 is equal to 5.34 34 cm per second. Okay, so this is the way we evaluate the velocity. Similarly, by substituting the values of this equation, you can get the acceleration as well. So please work it out by putting hs equal to 0.1 and this will be 0.3, and evaluate this expression. Then that will give f double dash of 0.3 as this minus 46.08 cm per second square. Okay, so these are two values. So this is one of the applications of this Newton's forward difference differences. Similarly, there are other problems in the textbook. There is one more illustrative example, that is a simple example. So please work it out, and the next class onwards we will discuss the Newton numerical integration, starting with Newton quadrature formula. Thank you.